Hello, welcome to Symbolic Manipulation. Today we're going to look at literal equations or elementary equations. And those kinds of equations only have variables. So we're going to do a little review, and just to remind yourself, when you evaluate, we're going to take some variable and it has some value, some number in this case that it will equal. So in this case, if c equals 5, then if given an expression c plus 6, all you're supposed to do is substitute 5 in for c. In this case, 5 plus 6 is 11. So you want to work with the order of operations in this very basic example. So a little thing that I kind of helped remind everybody here was, our little Pemdas, or our order of operations. So all I'm saying here is that if we're going to evaluate, which is knowing a certain value for a variable, some kind of thing to input, that means we're just finding a value given an input. So we usually work with Pemdas, so we do the parentheses, exponents, multiplication, division, addition, subtraction. When we are solving a particular equation, especially in the literal sense, we can just read what's there and do the exact opposite. And this makes things a lot easier, especially if we know to group, for example, addition and subtraction as being inverses or the opposite operations. Likewise, multiplication and division are also inverse operations. So the opposite of multiplication is division. The opposite of addition is subtraction. So just as a little reminder that when we generally solve a literal equation, you're going to work in reverse order of operations or reverse PEMDAS. Try to get rid of the addition and subtractions before the multiplication and divisions, the exponents and parentheses. There are certain little things you can do to change things, but try to start off in this order, and you'll see hopefully you'll see what I mean. So when you solve a literal equation, an elementary equation, okay, this is just a basic idea. So if you're given an equation, 5c plus 6 equals 11, then we want to read just the left-hand side of this. So what do we mean? Here is the left-hand side of this equal sign. Here is the right-hand side of this equal sign. So there's kind of like this little barrier here between the left and the right. So one way to look at it is we're saying 5 times some number c, that would be this piece right here, 5 times some number c, and then we're going to add 6 to that number. So that's what we're getting down here. So we just write it out in English first so we can get a better idea. And then what we want to do is perform the exact opposite, or the inverse of what we're talking about. And that inverse is subtract 6 and then divide by 5, because the opposite of a positive 6 or an addition of 6 is negative 6 or a subtraction of 6. 5 times some number, well, the inverse is taking that number and dividing it by 5. Oh, okay. So if that's the case, we have our first basic example, and we look at it as example 1 down here. And we can see that we're just doing the basic technique of what we've all learned before. But the reason why we're subtracting 6 first is because it's weaker than the multiplication, as indicated by PEMDAS. If we start with the addition and subtractions, which are the weakest of the orders, and start going backwards towards the multiplication and division, which are a little stronger, right? Then it makes our problem a lot easier to solve. So we subtract 6 and then we divide by 5. And we find that c is equal to 1. And you can check this by just substituting that 1, right? If I take c, which is 1, so whoops, I don't want to do that. Let's put that right back there for a second. So c is really 1, right? So that letter that variable is the same as this 1. So if I plug it in, 5 times 1 is 5, plus 6 is definitely 11. So you can always check and actually tell the instructor whether or not you're correct or not, which is something that the professor or the teacher would really like to hear. So let me just remind you about something over here. And if I have a little note, I'm just trying to make it a little bit easier for you to see, but when you solve elementary or literal equations, you are working Pemdas inversely. And I'm hoping that you kind of get that. So I'm going to say it a little differently, and I want you to remember back to the first class if you can. And if you can, think about juggling. Remember that little experiment I sort of did with juggling? And we were just remembering about the arc and talking about patterns and rhythms, but it also had a different reason, and I'm hoping you see it over here in the little area I'm circling now. So the way I look at example 2 is saying opposite sides are opposite operation or signs. So if the left-hand side equals the right-hand side, what must be positive on the left will be negative on the right. If it is negative on the left, what do you think it'll be on the right? Yeah, it's its inverse. It'll be positive. So all we did here was do what? Well, I realized the positive 6 was on the left, so I jumped over the little juggle and I subtracted 6. Or another way to look at it is positive 6 on the left is negative 6 on the right. And you have 11 positives and 6 negatives, so you have 5, which is what we have indicated in blue below. And the next thing we do is I'm just indicating that I'm going to be dividing both sides by 5, because why? On the left, I'm multiplying by 5. And the idea is to always isolate or get alone the variable in question, in this case, C. And you can look at them a lot of different ways, and I'm hoping we showed you that in class. So, little review is over. Let's go back to looking at formulas and using our symbolic manipulation techniques here that we just sort of briefly reviewed. Now, over here we have a problem. It says solve for the given formula for W. Okay, well, what is a formula? A formula is something in loose terms right now that gives a solution to a problem that someone may want to understand. The formula breaks it down so that a computer itself can work it out very quickly. The math behind formulas can be actually quite interesting. We'll be able to dig around with those sometime later, perhaps. But you can see here that I have some rectangle, and I have the area of the rectangle is equal to the product of the width and the height. Now you might know it as length times width, but right here what we have, for example, is the width, and over here we have the height. So we're just finding all of the space inside. Anyway, what we want to do is we want to solve this for W. So I let us know what the variables stand for. That little A, well, that big A with the little rectangle, like subscripted there, it means just a little below the A. That's just saying that's area of the rectangle. W is width and H is height. So that way we have some indication of what we're looking for. So originally what we do is we just rewrite the equation. And then we read the equation. And remember to ask questions. Like, what does the equation say? Well, if you read it in one way, you might say it's the area of the rectangle is the product of its width and height. Another way you might look at it is width times height, or W times H. Well, if you look at it in that way, then you just ask yourself, well, what is the opposite or the inverse to multiplying by H? And clearly that's dividing by H. Because when you multiply and divide by the same variable or number, like 5 divided by 5, you get a factor of 1. So I'm just going to divide both sides here by h. And now we have our solution is the area of the rectangle, divided by h is going to equal the width. So if you break it down into what the equation is saying, and you kind of keep in mind that you're just looking at symbols, then it's not so bad, right? So obviously I reported the solution. The second example I have here is the area of a triangle, and I thought it would be nice because it gives me a little bit of time to remind you about a little thing real quick. If I take any number and divide by 2, remember, that's taking 1/2 of that number. If I take any number and divide it by 3, that's like taking 1/3 of that number. If I take a number and divide it by 4, you guessed it, that's 1/4 of a number, and this continues. So when we look at this process up in here, and it says 1/2 times this b times h, well, what does that really look like? Well, it's really maybe like something like this down here. So what we're going to do is I'm just going to clear this out for a moment. Maybe just put it over here as a little special note, like that. And we're going to rewrite the equation. So I'm going to just copy it here and bring it down, so that way we can see it. Now, what I did was I tried to put it together in some context again, so you know what the h is, and you know what the b is, and you know what that a and the little subscript of a triangle, which is the area of a triangle. The b is the base, and the height is the h. So, okay, let's work it out. Let's read what it says. It says 1/2 the base times the height. So I have, what does the equation say on the left-hand side? Well, on the right-hand side, that should have been 1/2 of some number, base times height, or base b times height h divided by 2. And if we look at this component right there and rewrite that formula above for the area of the triangle, then what we can say is this. I can actually recopy this for one moment. And try to rewrite it that same way that we're reading it over there. So I'm going to just take this out for a second. Not really a second, but a little while. There we go. Delete, delete. And then I'm just going to move this over here a little bit. And then I'm going to go and divide it all by 2. And these two things are saying the same thing. They are exactly the same gosh darn thing. And it's following this principle right here, that if I divide a number by 2, I'm really taking half that number. Or if I'm taking half of this number, I'm really taking that number b times h, whatever that number is, and simply dividing it by 2. Okay, so what's the opposite of this? It's multiplying by 2 and divide by b. Oh, okay. So let's do this in steps. So 2 times this crazy looking variable called a, so it's capital A, little triangle. So that's a variable. We are then going to have it equal to what? B times h. So what did we do to both sides? We multiplied them by what? 2. In essence, to show you that step quickly, is that we multiplied both sides by what? 2. And that crossed this little beastie out, or created the factor of 1. And now we have to just simply solve this for h. So what's the opposite of multiplying by b? Well, I'm just going to divide both sides by b just to show you real quick. So there's that, there's b, and there's b. You can see that the b's will give you a factor of 1, isolating or solving for the variable of interest, which will be h. So watch how I say it here. What I want to do is realize that all I'm doing is solving this, so I'm going in reverse. So there's my 2 times the area of the triangle. And then all I want to do is divide it by b, and then set it equal to h. Now, that is the solution. Why is that the solution? Because it is now isolated for that particular variable, in this case, the height of the triangle. Okay, let's go to the next one here. I've got a couple of things here, and this one's a really nice and easy one, I hope. So let's just kind of go through it kind of quickly. We've got the ideal gas law, the noble gas law, and it's PV equals nRT. Now, you can figure out what all these mean later in maybe one of your chemistry classes. So let's just give it a try and see if we can solve it for n, that little red variable. Notice I'm trying to keep it isolated in some respects. Somehow I'm trying to make it stand out a little bit differently. So I'm going to recopy, well, not recopy, I'm just going to copy it. Oh, okay, here we go. Okay, anyway, so the first thing is that I realize that I'm only looking at the right-hand side. That's the big thing that I want to look at. And I notice that all of the variables have multiplication between them. How do I know this? Because there's no operation between them. There's one n, one r, and one t. And therefore, that's all multiplication. So I'll divide first by r. So why not? We'll do it the old way here like this. So we divide by r, we divide by r. We cross those out. That's what we usually say, right? So then we have PV divided by r is equal to NT. Now I'm just going to cheat here and just make a copy of this n. There we go. And now you can see this crazy looking thing here, right? Well, it's a little fraction. It's not really crazy, right? So now I've just got to get rid of the n. So I'm going to divide both sides this time by t. And it'll look really weird, but I'm hoping you see what I'm doing. See how I'm multiplying by t, by n, and now I'm dividing by t? So now I'll divide also by t. If you don't like that move, I can show you what you would be looking at. You would be looking at this, which would be divide by t here, and then you could make the one radical step that says it's PV divided by r divided by t, and if you see how that works, right? What do you guys remember how we divide in this format? We multiply by the reciprocal, right? So that would be what? PV divided by r times 1 over t, which then gives you PV RT. Or, therefore, n equals PV over RT. Now, if you see what we could have done right away, we could have just simply divided both sides by RT and saved ourselves a lot of time. So let me recopy it and look at number 2, and you can pay a special note over here to what I wrote. So in this case, I'm just going to do the one-step method because I can see that it's n times r times t. I divide by RT to both sides. I get PV divided by RT equals N, and we are done. It pays to read the literal equation. Now, time's getting short, so let's move on to, we're going to look at solving a basic given formula. And this is nothing really, it's just kind of made up, but it's more of an equation than a formula right now because I can't link it to something specific for you. But remember to ask the questions, right? That's what you want to do. You want to ask the questions. So what is the sum of A plus B divided by O? Okay, well that's a good question. What is the sum of AB divided by? Well, that's divided by 2. We can see it right here. It's divided by 2. Okay, well, let's see about another question. What is the N divided by? That little question right there. You can see it's divided by 3. So you can't separate the terms. Maybe you want to pull them out for just a second. You see how that's just the N divided by 3? So when it says, what is the N divided by? Well, it's divided by 3. So we'll just put that little guy right back. And right 3. And then we might want to ask ourselves a question like, what happens when you divide a number by both 2 and 3? Well, what do you think you're dividing that number by? Well, you're dividing it all by 6. And let's see. If we asked ourselves, what's the inverse or the opposite of dividing by 6? Well, that is multiplying. So, I'm going to take the whole gosh darn equation and I'm going to multiply it by 6. Now, you can do the little trick that I showed you within class where you just match them up and you write the, remember this? Let me just move this out for just 1 second. Remember this? I said you just match them up, 2 times 3, you see the 2 there, you see the 3 there, and you play the match game. You'll see what I mean in a moment. You don't really remember. So let me move this 6 back up where it belongs, and then do the distribution. Now, watch very carefully how I'm going to look at this distribution. I'm going to take each piece apart. So the first one is going to be 6 times this beast right here, this first term. So what I'm going to do here is I'm going to take it out for a second, just to make it a little easier. I'm going to pull this 6 out over here. I'm going to make it look a little different. If I had this scenario, then I can simply take this out of the picture for, I can take the A and the B sum out of the picture for a second and think of this as 6 divided by 2. So you see what I'm doing here? Isn't 2 times 3 the same as 3 times 2? Well, I'm just doing something called the commutative property. Wow, that's cool, right? Because 6 divided by 2, that's easy, that's 3, right? Oh, okay, so maybe you can see where I get this next piece from, okay? Let me bring it back up here. Oh, hold on, let me get rid of these. Let me put this back, and then this, and then go, ooh, boop, boom, and be like, yeah, that's right. Okay, so now we know that we have 3 times what was left over in the numerator. In this case, the sum of A plus B. The next one we're going to do is we're going to take this, I used red already. we're going to use green. And we're going to say 6 times this beast over here, this secondary term. And I'm hoping you can see it, but let's pull this out again real quick. So this is going to be this right here. So we're using the distributive property, but remember we can use the commutative property inside that property. So I have this set up right here, and we'll just put the parentheses here for a second. So do the trick again. Instead of saying 6 times n to get 6n and then divide it by 3, because we know that multiplication and division are inverse operations, it doesn't matter really how we do it as long as we're looking at one specific term. So here's the n. It's going to pop out for just 1 second. Here's the 6. What's 6 divided by 3? Well, you got that, right? 6 divided by 3? Yeah, you know, it's what, 2? Okay, so there's 6 divided by 3. And that would give you 2. So maybe you can see what I'm going to write next. Because we all know that everybody, well, not everybody, but most people simply just don't like fractions for some reason, or rational numbers. So maybe you'll see how I'm writing this now. What was that? 6 divided by 3? Well, that gives you a 2 with the n left over. And then we still have to have it equal, and don't forget to distribute the last piece here. That would be 6 times k. Because you have to multiply this outside number, right? Right? That's the old way of saying it. But we're going to say we're going to distribute the 6 over the equation. So 6 times k is simply 6k. Now, all we have to do is solve for n. But there's a couple of ways you can do it. You can distribute again. That is one method to do it. So I'm going to break this down. Well, I'll just do it this way. Maybe you see the easier way, and I'll just do it very quick at the end. But I'll do the second distribution. So that gives me 3a plus 3b plus 2n equals 6k. But remember, what are we looking to get isolated or to get alone? We're looking for that variable right there to be all alone. That means we have to get rid of what? Well, we have to get rid of this 3a. Well, what's the sign on that 3a? It's positive. It's on the right-hand side. So if we move it over to the left, it will become what? Negative. So we can just put it right here, minus 3a, just so you can see how we're processing this problem. And it's just, like I said, juggling, right? Plus 2n equals 6k minus 3a. Now, I'll look at, I don't know, what? The 3b, right? And the 3b is positive as well. It's on the right, it's on the left, so I'll bring it over to the right. And then it will also be what? Negative. So I'll put that down, minus 3b. And then I'll carry everything else down. This is now 2n equals 6k minus 3a minus 3b. And then I will divide everything by what? What do you think? Yeah, it's 2, right? It has to be, because we don't want to know how many 2 of these n's are. What we want to know is what one of these would be. So now we have n equals 6k minus 3a minus 3b, all divided by 2. And you can simplify this, because you can see here 6 divided by 2. Well, that gives you 3. So that's 3k minus 3 over 2a. So that's minus 3 halves a. And then you can do the last one, minus 3b divided by 2. Or simply say minus 3 halves b. Now, either one of these is acceptable. So, very good job. Okay. The last thing I'm going to say is the question for another day is, what is the inverse for the square root? And hopefully by that, we'll leave it there. Hopefully this helps, and good luck on your problem set. Remember to go and check your math lab. Have a good day. Bye!